So we're going to work through another example of a perfect square trinomial and how you can verify that it's a perfect square and then factor it. The only difference in this case compared to the previous one was that the middle term in the first example was a positive and now it's negative. So this means we're checking to see if it fits the pattern of a squared minus 2ab plus b squared, and therefore would it be equal to this, rather than the previous example where it was plus 2ab and then the actual final pattern was a plus b squared. So this sign changes what we're actually looking for in this case. We still have to look for a couple things. First is, are the first and last terms perfect squares? And then secondly, is the middle term equal to negative 2 times the square root of c times the square root of ax squared? We have to look to see if it's equal to this, now with the negative 2, because we want to know if it actually fits this pattern of subtract 2 times a times b. So that's the one difference compared to the previous example we saw. So the first thing that we want to do is we're going to figure out the square root of ax squared and the square root of c, because we want to know if the first and last terms are perfect squares. So the square root of x squared is x, so we get a variable with no fractional exponent, so that's good, perfect square. And then for the square root of c, the square root of 36 equals 6. So that's good. We've proven that the first and last terms are perfect squares. Another shortcut for you to know if a variable is a perfect square is if the degree is even, an even number. So x squared, x to the power of 4, x to the power of 6, x to the power of 20, those would all be perfect squares. So then second question, is the middle term equal to negative 2 times the square root of c times the square root of ax squared? So let's try that. If this is kind of our first check, this is our second one, so there's 1, this will be 2. So negative 2 times the square root of c times the square root of ax squared, we're just going to say equals negative 12x, and just we want to prove whether or not this is true. So negative 2 times 6 times x, does it equal negative 12x? Negative 2 times 6 is negative 12 times x. So negative 12x equals negative 12x. So we're good with that too. We have proven that the middle term is equal to this. So now we have some proof that this perfect square trinomial is actually a perfect square and would fit this pattern of a squared minus 2ab plus b squared. So the red part, that's our verifying. If you're asked to do verify as part of a problem, you would need to do that. But if you're only asked to factor, then you could use the previous strategies or just substitute numbers into this formula. So we have x squared minus 12x plus 36. So this is going to be our a squared term, and this is going to be our b squared term. So we should be comfortable now to not have to see the work for this. We just know that a is x and b is going to be 6. So in this case, since we are now going to fit this particular pattern, a squared minus 2ab plus b squared, that means the factored version is going to become a minus b squared, which will be x minus 6 squared. And then that is the whole answer. So after you do the verifying that it is a perfect square trinomial and can fit that pattern, you just identify what's the value of a and what's the value of b, you sub it into that formula, and you'll get the factored version.